Howdy. If you're implementing an Umbraco website and you need to implement custom C# code, then you should be making use of dependency injection, in my opinion. Now, dependency injection not only enhances code modularity and testability by decoupling components, implementing it should provide you with more flexibility, facilitating a cleaner and more maintainable codebase. Now, over the different versions of Umbraco and .NET, how you approach implementing dependency injection has changed slightly. And for that reason, I thought I'd create an Umbraco specific dependency injection deep dive video. So, if you want to learn how to easily implement DI, as well as learn some pro tips, then this is the video for you, my friend. The first thing that you need to understand when thinking about dependency injection with an Umbraco, or just normal .NET if I'm honest, are service lifetime scopes. So a lifetime scope will determine how your injected dependency is going to behave. Now, using the default .NET DI container, you will have 3 different types of scope to pick from. Now, the first type of scope is called transient. And the most important thing to know about the transient scope is that this is the recommended scope that you should always use. Now, transient is usually the default scope type for any dependency framework. Unless you have a specific reason to use a different type of scope, always start with transient. So when you set a dependency to be injected using a transient scope, whenever the framework encounters a request to inject your dependency, it's going to create up a new instance of that class every single time. So every single time you inject a dependency, it's always going to be a new object. Now, I'm assuming the second type of scope is probably the one you're most familiar with, and that is the singleton scope. Now, when you use a singleton scope, the framework will create a single object for that class, that dependency, whenever it first encounters a request to new up an object. And it's going to reuse that object through the entirety of the application lifetime as soon as it's first created. Now, the final type of scope is called scope. And when you set your dependency to be injected using scope, a new object will be created on a per scope basis. Now, the key to understanding the scope type is what's included or what's the definition of a scope. So understanding scope is pretty simple. Let's say we've got this little guy here. I'm going to call him John. What a legend. And basically, when he requests a page from your website, a request is going to get sent to IIS. Now, the first time that the framework encounters some code that needs your dependency, it's going to create a brand new object. Now, this object is going to be shared the entirety of this request, and it's only going to get disposed when the end HTML or API data, whatever it might be, is sent back to the browser. Now, as a fun fact, there is a slight technical advantage for you using a scoped lifecycle, and that is that your server should consume slightly a fraction of a little bit less memory. And the thinking is pretty simple, is that on a per request basis, if the server only needs to keep one object in memory, then this is going to consume less memory compared to an approach where it might need to keep 4 or 5 different objects in memory at the same time. Now, transient still is the recommended de facto thing that you should pick, and I'll cover why shortly. However, those are your 3 options. So the next thing to do is look at how we actually implement this type of dependency injection within our Umbraco website. Righty-o. So I think the best way for me to show you how you can set this up yourself is to show you via my starter kit. So the good thing to know about this is that if you want to download all this code so you can have a play around, debug it yourself, you can. This starter kit is available from my GitHub. So the link is in the description below. It's pinned to the homepage. And while you're there, don't forget to star me. So the first thing that we need to do in order to configure our dependencies is to register stuff. And in Umbraco land, we do that by creating these things called composers. So the good news is that composers are dead simple and they'll only take you a few seconds to set up. Now, the first thing you need to do is decide where in your application you want to create your composer. In this application, you can see that I've got a folder called composer and I've created a class called registered dependencies. Now, obviously, you can put this file and call it wherever you want to, but the key thing in here is that we're implementing from this iComposer interface. So iComposer comes from Umbraco CMS Core Composing, so we need to add in this using. And the key bit is that you'll need to implement this method. And the method is public void compose iUmbraco builder, and this is going to give you access to this builder object. Now, that's basically all you need to do in order to create your composer. So with this bit of code, when your application launches, this compose method will automatically be called on application start, and all the code in here will be run. And this is the reason why the next step is to register our dependencies within our compose method. Now, in order to access the transient, scoped, and singleton lifecycles, we can access the services property. So we do builder, services, and then add transient, add scoped, or add singleton, depending on which lifecycle you want to use. Now, the next job for you is to map your dependency to your object in your class. So for this example, I've created an interface and it's called iTransient. If I look in here, there's nothing special. You can see it's a custom interface I've created, and it's got a property called string ID with a getter. And this transient interface here, this dependency, I want to map it to a class that I've called getID. So again, this is a class that I've created. And if I look in here, again, there's nothing special. So it's just a public class. It's implementing from the iTransient interface. And basically, whenever you're doing dependency injection, regardless of Umbraco or .NET, this mapping of concrete class to dependency type is key, because without it, you're going to bump into a bunch of problems. Now, before we move on, I'll quickly show you the code in the constructor here, because what I'm going to do is give you a real life example about how the different types of scope can affect objects being passed in. So the code here, pretty simple. Basically what happens is that every single time that a new object gets created using this getID class, it should be assigned a brand new random ID. And I'm doing that, just doing the simple GUID new GUID toString. So I said, nothing too complicated here. The important thing is that this value of ID should be different every single time a new object gets created or injected. So I've got a controller, and it's an Umbraco controller because I'm inheriting from render controller. And you can see here, I've just got all my different types that we've created. So remember, this is going to create exactly the same object. However, I'm injecting a iTransient, an iTransient, an iScoped, and an iSingleton. Now, if I look within my code, you can see that the ID for transient 1 is EAA. Well, hopefully you can see that because it's tiny. Now, if I look for the ID of transient 2, it's 8DD. Now, because both of these are being injected as a transient, this is expected. And basically, each time that the framework sees a request to inject an iTransient, it's going to create a brand new object here. And this is why the ID is always different. Now, next, I've got two scopes. And if I look at the ID for scope 1, you'll see that it's 575. And if I look at the ID for scope 2, you can see that this is also 575. So even though we've got two different variables here, they're actually referencing and referring to the same object. And finally, if we look at the singleton ID, you can see it's 313. So if I now finish this request, if I refresh my page, you'll see that my transient IDs, they're all different. You can see my scope ID, even though they're being shared, they're now different. However, if I look at my singleton ID, this should now be 313 because the object is being created at application start, and this object is going to be kept around for the entirety of your application lifecycle. Fantastic! Now that you understand that setup configuration, you'll hopefully be able to understand why transient should be your go-to lifecycle scope. So let's say that we have two different classes, one which is called number and one which is called alpha. Sorry, my writing is very much like a doctor's handwriting. Now, number we're going to set as a singleton, and the alpha is going to be a transient. Now, let's say that number calls the alpha class in order to get a letter. So let's call it A here. And then it's going to expose this to a public property. I'm going to call this property alpha or alla. Perfecto. So let's think about how this works if we try to access this in code. Let's say that we want to access number within a controller. So remember, this is a singleton, and once this object, let's call it ob1, is being created, it's going to exist the entirety of your application. Now, when num1 loads, it's going to instantiate or access alpha. And remember, alpha is set to a transient. So I'm expecting alpha to be different each and every time I call it. Now, let's say that alpha is going to return the value A. Now, the next time that we call num, we're going to be using this same object. So object 1 is going to be created. Now, because object 1 already has access to alpha, we're not going to create a brand new version of alpha. It's basically just going to use the object inside of it because the constructor here is already being called. This means that every single time that you use num, we're always going to be returning A for alpha. Now, I'm guessing most people might be thinking, yeah, big deal. What are you complaining about, you numbnuts? But what can happen in production is that if you're dealing with a complicated dependency chain, say this one, for example, what will happen is several levels deep, you might have a singleton, which then causes a transient. And what can happen is that your cache doesn't work properly. You're going to get inconsistent data. And trust me, and when I say trust me here, from personal experience, trying to debug and find these types of errors in a large production system is a complete ball ache. I personally wasted a week of my life trying to figure out why some API wasn't returning data correctly once every hour, and it ended up being an issue like this. So hopefully you can now understand this is the reason why the recommended industry approach is to always use a transient, because you can never have these weird caching dilemmas with a transient inside of a singleton ending up being a singleton. So transient all the way makes debugging much easier and you avoid that dependency chain hell. That covers everything that you need to understand in order to configure a single dependency. However, in real-world projects, you're going to have to deal with a lot more than a single registration. Now, since .NET 5, we get access to a free built-in DI container. However, the out-of-the-box offering isn't the best for making your life as easy as it could be when it comes to setup and maintenance. Now, do not get me wrong, there's nothing wrong at all with the built-in .NET dependency container, but it was deliberately built for simplicity. Now, one limitation because of this simplicity is that it only supports the manual registration of dependencies. This means that every single time that you add a new class that you want to inject somewhere, you're going to have to also remember to update your registration configuration as well. Now, I am pretty lazy, and manual registration is a deal breaker for my projects. And I think a better approach is to use a framework that supports assembly scanning, so you can avoid the reactive nature of registering each service explicitly. Now, for anyone using .NET for ages, you're going to know about the plethora of different alternatives you could use to replace the default .NET container. So this list includes Autofact, Ninject, Unity, Simple Injector. There's a bunch. Now, I'm not here to provide a review of the best DI framework in the marketplace today. I personally think that from .NET 5 upwards, there's no need to completely rip out and replace the out-of-the-box solution. Instead, my preference is to enhance it, and this is why I use an additional package within my projects called Scrutor. Now, the nice thing about Scrutor is that it complements the default container rather than trying to reinvent the wheel. The added benefit of this is Scrutor is also pretty easy to install and configure. Now, the big benefit you're going to get from installing Scrutor in your projects is assembly scanning. And a Scrutor will allow you to create registration rules based on configurable criteria. And this capability will significantly reduce the amount of manual, boilerplate, dependency registration code that you're going to have to write. Now, on top of that, Scrutor also provides support for decorators and open generics. Again, this is something that the default container is rubbish. So installing Scrutor, dead simple. Let's go to NuGet. So manage NuGet packages. And then all you need to do is search for the package, which is called Scrutor. So it's this entry here by Christian Hallang. And at the moment it's on 422. Now, after you've installed Scrutor, we can go back to our composer, and basically now we can delete all of our one-to-one mappings. See ya! So now that we've got a blank slate, we can use Scrutor to write some configuration to automatically register stuff for us. And the code we need to add is going to look something like this. So we're still going to be using builder.services. However, this time we're going to be using scan. Now, the first thing we need to do is tell Scooter, tell the DI container which assemblies we want to include within our scanning. Now you can see here I've got type of IMyInterface and I'm doing .assembly. And you can see I'm doing type of register Umbraco components.assembly. So if I go to Solution Explorer, to include a class library, all you need to do is go into that library and then basically pick a random class or interface. So you can see here I've got IMyInterface, and then all I need to do is add it within my from assembly scanning, and this is going to pick up everything in that class library for me. Now, it's probably worth pointing out that there are other ways of registering assemblies. However, the nice thing about this approach is that it gives you type safety. Now, let's say that you tried to register your assembly by taking this name johndjones.core and then hard code it in config. If you ever refactored your class library and you changed the name, when you compiled your project, you wouldn't get any warnings and your site would break. And because of this limitation, this is why reflection is always the preferred approach for registering assemblies here. Now, next up, you can see we've got add classes, and add classes basically tells the framework to scan all the classes contained within the class library for potential auto registration. Now, after that, we've also got this use registration strategy skip. So the reason why we need this line is because all this configuration stuff, it's all brilliant. It's going to register the majority of things that we care about. However, you're always going to bump into these oddball scenarios where you're going to want to change the default behavior. Now, when this happens, you're probably going to have to write some manual code yourself. So maybe you want to set a singleton. And this line saying registration skip basically means that if it finds some manual registration code, then use that and ignore the automated rules instead. Simple. Now, after this, we've got as implemented interfaces, and this line is adding the auto registration rule. And basically the logic within this rule says that if you create a interface called iRegisterDependencies, what we're going to do is ignore the I here, and then we're going to scan the assembly for a class which has got a matching name. Now, if a matching name is found, then this is the class that we want to use whenever you see this being injected. Simple. And then the final line within our configuration should hopefully be pretty obvious by now. So we all know that the transient lifetime is the scope that we should use by default. So at the end, we're saying make all of our dependencies a transient using with transient lifetime. And with those handful of configuration lines added into a composer, you're going to have automatic dependency registration for you with the ability to override anything manually if that takes your fancy. Now, before we part ways, the last pro tip that I'd like to share with you is around circular references. Now, it's very easy if you reference your website project within this automatic assembly scanning to get yourself into problems. So you can see here that I've added in a reference to register Umbraco components. And if I look at this, this is in my website project. You can see here that I'm actually referencing a composer. Now, if I actually try and run this website, what will happen is I should get some sort of funky error. So the error reads, some services are not able to be constructed. We've got some sort of clash with a transient implementation type, which is going against the published models block. A circular dependency was detected for the service content I published element. Now, it's because of these potential types of errors, I always recommend that you put all your custom code within a separate class library. And then when you're setting up your dependency framework scanning, all you need to do is reference your separate class library, and you don't need to worry about interfering with potential Umbraco application startup logic as well. So this is a pro tip that I recommend that you follow in your own projects as well. And that basically really is everything you need to know in order to master dependency injection with Umbraco. Now, I hope you have found a lot of value in this video. If you want to learn more about this topic, then one, I have created a book which is all about Umbraco development, linked to on the screen right now and in the description. Now, this is part of a mini series all about Umbraco, so don't forget to subscribe. And if you want to see more Umbraco content on this channel, hit like. And my final parting gift to you is that if you're interested in learning more about Umbraco 13, Then on the screen right now is a link to a feature tour video I created all about what's included inside of Umbraco 13. It's pretty informative, so I recommend you look at that. Otherwise, until next Sunday, happy coding.